line 2, there we go. Now I get it. I was trying to figure out how that happened. So you all figured out, a couple of you figured out this distance. Can you see that?
Yeah.
Because this is 0.3 and this is 0.18. Okay, so let's clear up when we talked the other day about the distance between a point and a line, what did we say that distance had to be?
Perpendicular distance.
Perpendicular distance or shortest, both of which are the same thing. So shortest distance is the perpendicular. Same thing's going to happen for this. I want the shortest distance between these two lines. And the shortest distance is the perpendicular distance. That wouldn't necessarily have been obvious to everybody. So that's what we need, is the distance between two lines. And if we don't do that, right, if we don't say that the distance between two lines or parallel lines is the shortest distance, it wouldn't be unique, right? We could say, oh, that's the distance between two lines, or that's the distance between two lines. And just because it's on the, crosses the y-axis doesn't mean that we would let that be the distance. Okay, so the shortest distance is only one number. All the other distances would be many numbers, just like up here, right? So we want to be clear about what distance between two things that aren't just 2 points. Great problem, loved that problem. Nice and long. Something else from our menu today, anything else that caused you concern?
I have a quick question on that one. How did you get the 36/5 and the 63/5?
Okay, so on that one, I was intersecting my new line and line 2. Right. So I did this. Here's my line 1, and I chose 0.3. And here's my line 2. And what I did was, right, we constructed this line that's perpendicular to both. And I called this line y equals 4/3 x plus 3. And then I intersected it with, I'll draw this line as a double line, line 2, which was y equals minus 3/4 x plus 18. Okay, so to get this point, I set this equal to this. Okay, there's no other way to do that, right? We constructed so if you think about what we did in this problem, 1, we constructed a perpendicular line from 0.3 to intersect that new line with line 2. 3, that gives us an intersection point. And then 4, determine the distance between 0.3 and the intersection point.
I have a question also.
Go ahead.
Yeah, wait, why 0.3?
I picked it. It was
Oh,
easy to me.
Also,
I'm sorry?
We could just pick any point and then make a
Yep.
perpendicular over there.
That's
okay.
right. Any point on this line, you would have done the same thing. You would have picked a point, you would have constructed its perpendicular, Then you figure out the intersection point, and then finally determine the distance between those 2 points. And because this distance will always be the same because they're parallel, it doesn't matter. I love choosing 0 if I can. 0 and 1 are some of my favorite numbers because they're easy to deal with. Great question. Some people may have chosen this one down here, which would have been, I don't even know, 4? Like 4, 0. That's another one that could have worked nicely because it's got a 0 in it. Great.